This is a brief demonstration of the Forrest Manufacturing Pneumatic Blade Tensioning System. This is an optional feature on our smaller saws, standard on our larger saws. So a brief explanation. First off, if you're watching a video about bandsaws, you probably understand that the blade must be tensioned to run. So blades are tensioned in terms of pounds per square inch, or basically pressure. In practical terms, what that means is the larger the blade is, the more force is required to properly tension the blade. On most of this machinery, your correct blade tension is going to range something between maybe 12,000 up as high as 25,000 psi. More likely in the 15 to 20,000 psi range. And that's for any blade. You tension them up to a pressure. But the larger the blade, the more force is required to make that same pressure. There are two common mechanisms for tensioning a blade. The one you see on most small machines and the smaller machines that we sell, including the standard, is what we call a screw over spring mechanism. It does exactly what you sound like. You turn a screw down, it pinches on a spring, and that screw also tensions the blade. Everybody knows how this works. It's reliable as an anvil, but it's most often used incorrectly in that to really get a good, accurate blade tension, you need to use a blade tension gauge. And people just get lazy, they don't bother. They think, okay, I know what it sounds like, they'll come over here, they'll turn the spring, pluck the blade a few times, say that sounds about right. Typically, that method leads to over-tensioned small blades and under-tensioned big blades, because everybody thinks it just snap, it's about right. The way the math works, as blades get bigger, say from a ½ inch to 3/4 inch to 1 inch, they're also made of thicker and thicker materials. Say 0.25 to 0.32 to 0.45 and even 0.56 in the big blades. So what happens is, mathematically, as the blade gets bigger, the cross-sectional area goes up roughly as the square of the blade size, and so it takes exponentially more force to correctly tension the blade. So it might take, I should have done some math on this, but in round numbers, maybe it takes 200 pounds of force to tension a half blade. It might take 800 pounds of force to tension a 1 inch blade. And again, it varies depending on the thickness and width and application. But you can use a blade tension gauge to set these correctly. Most people don't bother. Also, the screw over spring, it gives a reasonably soft ride, but like driving in a car that has blown out shock absorbers, it can be a little bouncy. The upgrade is our pneumatic blade tensioning system, which this machine has. In this machine, we replaced the screw over spring mechanism with an air cylinder. The air cylinder has its pressure regulated by the pressure regulator valve and controlled by, in this case, a manual air control valve. So what we do is we provide a chart in the back of the manual for the machine that says if you're running a certain size blade, use a certain pressure on the gauge here to correctly tension. You set this once, and until or unless you change blade sizes, you don't have to mess it with again. When you want to change blades, or maybe you're good and you detension the blade at the end of the day when you're no longer working, flip a switch. Cylinder retracts, blade goes slack. Ready to work again, flip the switch, tension's up again. So we got a couple of advantages here. First off, we know we are setting the blade to the correct tension, and a correctly tensioned blade will cut better and last longer. Another advantage is, according to reports in the field, customers who have similar machines side by side with screw over spring and the air cylinder style pneumatic blade tensioning, they get much better blade life out of the pneumatic system. One theory is that the pneumatic system is just giving a smoother ride. Another theory is that because of this mechanism, they simply are getting the correct blade tension, where they only thought they were getting correct blade tension with a screw over spring mechanism before because they weren't actually using the gauge. Either way, with the pneumatic system, you get better control over your blade tension. When it comes time to change the blade, the screw over spring mechanism, it takes a couple minutes. It's not hard, it just takes a couple minutes, and it requires your operator to be a little savvy. Here, when you're ready to change blades, again, flick the valve, change the blade, flick the valve, the blade is correctly tensioned again. This machine has our standard manual air control valve. We also offer an electronically controlled version. So the manual valve, we have an electric solenoid valve here, run by a control panel. Big advantage there is I can do some smart things. For example, I can set the machine up such that if you don't have correct air pressure, the motor won't start. If the blade control valve is not in the right position, the blade is not tensioned, just because the switch is in the wrong place, then the motor won't start. And I can include a blade breakage detector. If you snap the blade or the blade's just not there for whatever reason, no matter what the status of the other parts, the motor won't run, or if it is running and the blade snaps, it stops. So it's a nice little safety feature. A couple more little application notes for those of you who already have these systems and want to properly maintain them. Whether you have a manual valve or the electronic valve, this is a four-way valve. And we have two what we call speed control mufflers. These little thumb-sized pieces of brass here, they serve two functions. First off, they are a muffler, such that when you tension, detension, and the air comes rushing out, it doesn't whistle and deafen you. The other feature is these have little needle valves installed in the ends of them. The needle valves regulate how fast this can go up and down by regulating the rate at which the air can flow out. So if you open these all the way up, this will slam up and down. If you pinch down on them appropriately, it moves up and down in a controlled manner. So if you find that this thing is moving up and down and slamming up and down, or if you find that it won't move at all, it might be that these are set too far out, too open, or they may have been set too far in, they're completely choked off. On very old machines that have been in service for decades, it is possible sometimes that lubrication oil, if you're running lubricated air in your plant, lubrication oil and dirt may clog these. Soak them in turpentine or WD-40 and it'll clean them out. That typically doesn't happen. These machines we use permanently lubricated cylinders, so you do not have to run air tool oil or a lubrication system on these. They'll run fine, dry. And really, you're not cycling these things so many times with lubrication is such an issue. So if you have any questions about the application of our pneumatic blade tensioning system, or want to discuss any other sawing issues related to Forrest equipment, please feel free to call or email us at Forrest Manufacturing. Thank you.